Okay, section 32, example 2. A machine is used to put drawn pins into boxes. A sample of 8 boxes is taken and the number of drawn pins in each is counted. The results are shown below. Calculate the mean standard deviation. Okay, so the mean is given by adding up all the numbers in the data and dividing by the amount of numbers in the sample. So it's going to be 102 plus 102 plus 101 plus 98 plus 99 plus 101 plus 103 plus 102 divided by, and there's 1, 2, 3, 4, 5, 6, 7, there's 8 numbers in the sample. So I'm going to enter that into the calculator. That will give me a mean of 101. So that's the first mark. I now need to work out the standard deviation. So standard deviation, just give myself plenty of space for this one, is when we set up the 3 columns. So x minus x bar, and x minus x bar squared. So x is all the numbers in the sample. So there's all the numbers in the sample. X minus x bar. So for each one now, I do 102 take away 101. That's 1. Square it, and I get 1. I then do 102 take away 101. 1 again, square it, and I get 1. 101 take away 101, 0. Square it, and I get 0. 98 take away 101. Minus 3, square it, and I get 9. 99 take away 101. Minus 2, square it, and I get 4. 101 take away 101, 0, square it, and I get 0. 103 take away 101 is 2, square it, and I get 4. 102 take away 101 is 1, square it, and I get 1. I then total this column up to get this sigma x minus x bar all squared, and that just means total up. So 1 plus 1 is 2, plus 0 is still 2, plus 9 is 11. 11 plus 4 is 15, 15 plus 0 is 15, plus 4 is 19, plus 1 is 20. Next I use my formula. So from the formula sheet, standard deviation is sigma x minus x bar all squared all over n minus 1. N is just the sample size. So the sample size is 8, therefore the sample size take away 1, n minus 1 must be 7. So that's the square root of 20 over 7. So I just input that into the calculator, and that will give me 1.69. Part B now says a sample of 8 boxes is taken from another machine. This sample has a mean of 103 and a standard deviation of 2.1. Write down 2 valid comparisons between the samples. Okay, so there's the information. Sample A, the mean was 101 pins and a standard deviation of 1.69. For sample B, the mean was 103 pins and a standard deviation of 2.1. So I'm going to first of all comment on the mean. So typically, or in general, so typically there were more pins in boxes during sample B since 103 is greater than 101. So again, I've said typically, I've kind of hedged my bets, not saying every single time. I've talked about the context of the question, which is drawn pins in boxes, and I've made my numerical comparison. Alright, so that's statement 1. Statement 2 is comparing the standard deviations. So that's kind of comparing 1.69 with 2.1. So again, sample A, standard deviation was 1.69, and sample B, standard deviation was 2.1. So in sample B, there is a bigger spread of numbers of pins and boxes since 2.1 is greater than 1.69. So it's about measuring, talking about the spread, given the context of the question, which is drawn pins and boxes, and that's the end of the question. Okay, section 32. Example 3, Tom looked at the cost of 10 different flights to New York. He calculated that the mean cost was £360 and the standard deviation was £74. A tax of £12 is then added to each flight. Write down the new mean and standard deviation. Well, it's only 2 marks, there's not enough lot of work required with this one. If every flight went up by £12, that means on average, so every flight went up by £12. So if the mean was £360, it's pretty simple. The new mean is just £12 more, £372. Now remember the standard deviation, which is £74. Standard deviation is just a measure of spread. Now even though all the flights have went up in price, the spread of prices is exactly the same. It's just that each flight has went up by £74. So they're £74 dearer, but they're not any more spread out. Therefore, the standard deviation hasn't changed. The standard deviation is still £74. And that's the end of the question.